Hello friends, Namaste. Today in this class, today we are going to learn about the combined criterion rules. So in the previous class, we learned about single criterion rules. So where only one criteria is used to do the sequencing of jobs. But here what we are using combined criterion rules. So we are using more than one criteria to do the sequencing of jobs. Hence it is called as what? Combined criteria rules. Under that, today we are going to learn about Johnson's rule. In Johnson's rules, we have different types of problem. Under that, today we are going to solve one type of problem, that is model 1, n jobs 2 machines. That means there will be n number of jobs and it is having a 2 machines, and the processing of job has to take place in particular order only. Let me take with an example. So here they are given the processing time in minutes for how many jobs are there in the industry. There are 6 jobs are there, and there is a machine A and machine B. See, all the jobs has to undergo first in the machine A and then it has to go to the process to the machine B. That must be in the same order. So job 2 will be also in the same way, job 3 also in the same way. That is, first it has to be machine under machine A, then it will go to the machine B. So that is what n jobs 2 machines in the same order, in the given order. So depending upon the problem. Okay, so in this problem, we have to identify or determine order. That means we have to, what is the best sequence? We need to find out the best sequence. So next, time, total minimum elapsed time and idle time. So let me first explain you how to find out the order or sequence. So why we are doing all this circus means to minimize the idle time of the machines. If we minimize idle time, what happens? So we are going to get the more profit. That means we are reducing the waste. So that's why the main intention of doing all those things is to minimize the idle time of the machine and to use the resource to the optimum level. So therefore we can maximize the profit and minimize the losses. That is the objective of doing all those things circus. Okay, so now let us see how to do the sequencing. So for that, so in this, first we need to identify the minimum processing time. So where is the minimum processing time in this machine A and machine B? So we have minimum processing time for a 6 in machine B. See, we have, that means minimum processing time in the machine B. So therefore the job 6 has to be placed as late as possible. That means I am going to place it over here. Okay, it has to be sequenced as late as possible. Why? Because the minimum processing time is for machine B. That's why. So next, that is 6 is over. So next, so of leaving that, identify the next minimum processing time. So out of this, we are getting next minimum processing time. So here that we have for 4 for machine A. Got it? So we have the minimum processing time for 4 for machine A. So it is coming for machine A. So that is the first machine. Therefore, sequence it as early as possible. So therefore, I am going sequencing as early as possible. That is the first 4 will be taken for processing. So the 4 is over. So next, identify the next minimum processing time. So we have 3 over here as well as 3 over here. We can consider any one. So I am going to consider this 3. So this 3 is for machine A and job 1. So you have to place it as early as possible. So therefore it must be 1 over here. So this one is over. So next we are getting another 3 is over here. So that is for the job 5 and it is to the machine B. So therefore we need to place as late as possible. So it will be job 5. So next we left with job 2 and job 3. So out of this, which is a minimum processing time? So we have 5, right? So this 5 is for which one? Machine A. So therefore it has to be placed as early as possible. So therefore this is 3. Which is the remaining one? So 2 is the remaining one. Have you understood? So this is how we have to sequence the given jobs to the machines. Okay. Next. So now we need to find out that, so the order is over. So the next problem is to find out the total minimum elapsed time. Okay. So for that we need to construct a table. So what is the sequence? We have to write the sequence 4, 1, 3, 2, 5, 6. So in this sequence we are going to do the processing or machining of the jobs. So job 4. So what is the in time for the machine A? It will be 0. See here 4. So what is the processing time in machine A? It is 2. After processing in machine A, it will be the in time to the machine B. So what will be the processing time? 6. 2 plus 6. So that means after 8 minutes, the total job will be completed in machine A as well as machine B. So what is the next job we have? 1. So 1. What will be the in time of the job 1? So it will be after 2. Right? Next, what is the processing time for job 1? 3. 2 plus 3, it will be 5. Now, at what time job 1 will be mounted on job machine B? So whether it is 5 or 8. So if you place 5 over here, still job 4 is on the machine B. So therefore the in time for the machine B, it will be 8. Okay. So what will the machining time for 1? In the machine B, it will be 8. So 8 plus 8, it will be 16. Okay. So next one is 3. So job 3. So what will be the in time? It will be 5. Okay. So job time for machine A, it will be 5. Therefore it will be 10. So job 3. What will be the in time for the machine B? Whether it is 10 or 16? It will be 16. Okay. So machining time in the machine B will be 9. 16 plus 9. How much is this? It will be how much? 25. So in the same way 2. So the in time for the 2 will be 10. So machining time will be 12. So 10 plus 12, it will be 22. So in time the machine will be 25. So that will be 10. So this is equal to 35. Next for the 5. So the in time will be 22. The plus 9, that is equal to 31. So here the in time will be 35. 35. So that will be plus 3. 38. Next for 6. So in time will be 31. Plus 11. So that will be how much? 40. Yes, 42. So what will be the in time for the job 6? The machine B, it will be 42. Correct? What is the processing time for that? Only one. So it will be 43. Okay, got this? So what will be the total minimum elapsed time? So how much is that? 43. So what is the meaning of that? After 43 minutes, all the 6 jobs will be completed. I got this? So that is what called as total minimum elapsed time. Is that clear? Okay. So what is the next step we have to find out is the idle time. So idle time for machine A as well as idle time for machine B. So idle time for machine A. So that is equal to total processing time. So what is that? How much is the total processing time? So if we add all the processing time of jobs, So that will be the total processing time. So if you add all those things, it will be total processing time will be 42 minutes. Okay, so total processing time for machine A is 42 minutes. Okay, hold on. Sorry, not this one. So we need to find out what idle time for machine A. So that will be called total minimum elapsed time. Total minimum elapsed time. So how much is that? That is equal to 43 minus total processing time. So as I told, total processing is the summation of this one. So that is equal to, if you add all those things, you are going to get for 42. So what is idle time? So it will be 1 minute. So because processing time is given in what? Minutes. Have you understood? So in the same way, we need to find out the total idle time for machine B. So total elapsed time is 43. So what is the total processing time for machine B? You have to add this one. So that will comes around to 37. So 43 minus 37. How much is that? So it will be 6, right? Yes, 6. So the idle time for machine B is equal to 6 minutes. So this is how we are going to do the sequencing with the help of Johnson's rules. So what is that? Which type of problem is this? N jobs, 2 machines. I got this. I hope you understood. Thank you. Namaste. Happy learning.